Good morning. Today we will discuss a practical on screw gauge virtually. Students, this apparatus is a basic instrument which serve the purpose of measuring the diameter of a wire, or even we can measure the thickness of a glass sheet. This instrument is very useful for BSc as well as MSc students. So, it will be beneficial for all the students to learn about these experiments. So, before moving on to this experiment, I am going to tell you about the least count. In a lab, when we are using any experiment, then we must know about its least count. हमें किसी भी उपकरण का अल्पतमान पता होना चाहिए. हम एक सिंपल स्केल अपनी डेली लाइफ में यूज करते हैं. ये हमारे पास एक सिंपल स्केल है. ये मैंने आपको सेंटीमीटर वाली साइड इसकी दिखा रही है. इस सेंटीमीटर वाली साइड में अपन यहां देख सकते हैं कि 0 से 1 के बीच में 10 डिविजन्स हैं. So, the least count of this scale, that means the smallest division that we can measure from this scale is 0.1 centimeter. The smallest distance which we can measure from any instrument is a least count. सबसे छोटा खाना जो हम उस उपकरण द्वारा नाप सकते हैं उसको हम अल्पतमान कहते हैं. तो हमारे पास इस स्केल का अल्पतमान लीस्ट काउंट कितना हो गया? 0.1 सेंटीमीटर. ये स्केल अपन डेली लाइफ में यूज करते हैं. अब we will discuss about screw gauge. Screw gauge is shown here. This screw gauge is an instrument which can measure the diameter of a very thin wire, and even we can measure the width of a sheet of metal. तो यहाँ हम लैब में बहुत सारे एक्सपेरिमेंट्स हैं जिनमें इस स्क्रू गेज को यूज करेंगे. स्क्रू गेज के हेल्प से अपन किसी भी तार का व्यास नापेंगे, या लैब में हमें कोई भी एक शीट दी जाएगी, उस शीट की अपन मोटाई निकाल सकते हैं. अब हम डिस्कस करेंगे इस स्क्रू गेज की कंस्ट्रक्शन को. यहाँ पर ये एक यू शेप्ड का फ्रेम है. इस यू शेप फ्रेम से एक स्क्रूड स्पिंडल अटैच है. स्पिंडल के साथ यहाँ पर दिस इज अ थिम्बल. इस थिम्बल के साथ एक पिच स्केल अटैच है. ये जो स्केल है ये मिलीमीटर्स में इसके अंदर डिविजन्स बने हुए हैं. This is a pitch scale, and this is another scale which is termed as circular scale. This circular scale has 50 or 100 divisions. Clearly इसको शो करने के लिए मैं यहाँ पे आपको शो कर रही हूँ. पिच स्केल कौन सा है? पिच स्केल मेरा ये वाला है. इसके ऊपर जिसको हम मूव कर सकते हैं, ये मूवमेंट क्लियरली शो हो रहा है. दिस इज अ सर्कुलर स्केल. और ये जो नीचे वाला विजिबल है, दिस इज अ पिच स्केल. दोनों स्केल को अपन काम में लेंगे. ये सर्कुलर स्केल के अंदर जो अभी शो किया है, या तो 50 डिविजन्स हो सकते हैं या इसके अंदर अपने 100 डिविजन्स होंगे. अब स्क्रू गेज की हेल्प से अपन थिकनेस ऑफ ए मेटल शीट या डायामीटर कैसे निकालेंगे? ये चीजें निकालने के लिए दो पैरामीटर्स जो अपने को नेसेसरी हैं, दैट आर पिच एंड लीस्ट काउंट. तो सबसे पहले अपन पिच के बारे में देखते हैं. व्हाट इज अ पिच? पिच ऑफ ए स्क्रू गेज इज डिफाइंड एज डिस्टेंस मूव्ड बाय द स्पिंडल per revolution, which is measured by moving the head scale over the pitch scale in order to complete one full rotation. या इसको सिंपल लैंग्वेज में मैं कहूँ, पिच मीन्स डिस्टेंस मूव्ड बाय स्क्रू डिवाइडेड बाय नंबर ऑफ रोटेशन। क्या तरीका है पिच को निकालने का? ये मेरे पास स्क्रू गेज है, इसको अपने को कंप्लीटली क्लोज करना है। क्लोज करने के लिए हम इसको मूव करेंगे। ये मैं दिखा रही हूं, अभी मैंने मेरे स्क्रू गेज को सर्कुलर स्केल को टोटली क्लोज कर दिया है। अब मैं इसको 5 रोटेशंस दूंगी। 5 रोटेशंस देने पर ये कितना डिस्टेंस मूव करेगा वो अपन देखेंगे। क्लियरली शो करने के लिए मैं अभी आपको एक रोटेशन दिखा रही हूं। 0 वापस आ जाए, ये मेरा एक टोटल रोटेशन इसके अंदर कंप्लीट हो गया। यहां पर ये एक रोटेशन हो गया, तो डिस्टेंस मूव्ड कितना डिविजन्स आ रहे हैं? ओनली 1 डिवीजन इज अपीयरिंग। तो हमारे पास डिस्टेंस मूव्ड बाय स्क्रू आ गया 1 एंड नंबर ऑफ रोटेशंस की वैल्यू भी आ गई 1. दिस गिव्स अस द पिच ऑफ अ स्क्रू गेज. नाउ another important parameter that is needed is least count. Least count of a screw gauge is defined as pitch divided by total number of divisions on circular scale. As we have calculated that pitch is simply 1 millimeter and total number of divisions on circular scale, we can see there are 100 divisions on this circular scale. This is 95. 95 to 0 there are additional 5 divisions. So, there are total number of 100 divisions. So, we can determine the least count of screw gauge as pitch, which we have calculated 1 millimeter divided by 100, and this comes out to be 0.01 millimeter. That means 0.001 centimeter. So, we have determined 2 important parameters which are necessary for determination of diameter of a wire. Least count, which means the smallest division that we can measure from this screw gauge, is 0.001 centimeter. So, diameter can be measured accurately up to 3 decimal places. Now, I am going to tell you about the zero error. Students, we can see from this screw gauge that I am closing it totally, that 0 coincides with 0 of screw gauge. The one scale which was pitch scale, it is 0, and the circular scale 0, they are exactly coinciding. That means this type of screw gauge has no zero error in it. So, we can say that when 0 mark on thimble scale coincide with bottom line of main scale and the reading on main scale is 0, then in this case there is no zero error. Now, we will be discussing about positive and negative zero error. Zero error is equal to main scale reading. This is the main scale, which is also termed as pitch scale, and this is the circular scale. This circular scale reading will be multiplied with least count, which we have calculated as 0.01 millimeters. We are measuring the main scale reading and circular scale reading, both are in millimeters. तो हम हमारी शून्यांक त्रुटि का मान निकालेंगे। शून्यांक त्रुटि क्या होती है? अगर हमारे मुख्य पैमाने का 0 और वृत्ताकार पैमाने का 0 किसी भी स्क्रू गेज को बंद करने पर दोनों एक दूसरे के बराबर आ जाएं, तो वो स्क्रू गेज के अंदर कोई भी शून्यांक त्रुटि नहीं है। अगर ऐसी स्थिति नहीं है तो उसके अंदर या तो पॉजिटिव 0 एरर है या उसके अंदर नेगेटिव 0 एरर होगा। अब ये दोनों 0 एरर क्या हैं? पहली स्थिति के अंदर यहाँ पर ये मैं आपको दिखा रही हूँ ज़ीरो एरर इसके अंदर नील है, ज़ीरो और ज़ीरो एक दूसरे के ऊपर आ रहे हैं। सेकेंड कंडीशन के अंदर अगर हमारे पास सर्कुलर स्केल का ज़ीरो नीचे रह जाए और मेन स्केल का ज़ीरो ऊपर है तो इस एरर को अपन पॉजिटिव ज़ीरो एरर कहते हैं। We can clearly see in this picture, and we can also measure the readings which we will take on main scale and circular scale, and how we will correct our reading. So here we can see the observed reading. This shows the observed reading on main scale. We can see that there are two divisions. First, this is the second division. So main scale reading will be equal to 2 millimeter, and on the circular scale we will see the number of division which is coinciding with this main scale, and this division is 32. This 32 is multiplied with least count, that means 0.01, and this gives us 0.32. So the reading of the screw gauge here will be 2.32 millimeters. But this screw gauge initially has a error. What error it is showing? On completely closing the screw gauge without any wire, we will see that there are 7 divisions which are touching the zero line on main scale. The zero error here will be 7 multiplied by least count, which is 0.07. This type of error is termed as positive zero error. So in this setup we are having an positive error. So the actual reading will be 2.32 minus 0.07, which is a zero error. The reading will be 2.35 millimeters. 2.25 millimeters. So this is positive zero error. Now moving over to the negative zero error. Here the circular scale is having a 50 divisions. So we can see on completely closing the screw gauge, the zero of main scale is not coinciding with the zero of circular scale. That means there is some error in this setup. We will count the number of divisions which are below 0. Here the number of divisions on the circular scale are 2. This 2 multiplied by least count will give us 0.02 millimeters. And the reading which is observed is on main scale is 2 millimeters plus the reading on circular scale multiplied by least count. The circular scale reads is 23 multiplied by 0.01 will give 0.23, and the total reading will become 2.23 millimeters. But because of the zero error, we have to make a correction in our reading. The negative zero error which we have calculated is 0.02 millimeter. This is negative zero error, so we have to subtract it, and subtracting this negative zero error, the actual reading will come out to be 2.25 millimeters. So this is a zero error which we must take into account while taking the readings of a diameter of a wire. Now I will show how to take a reading. For example, we have to find out the diameter of this sphere. In order to find out the diameter of the sphere, first of all, what we have to do? First of all, we have to find the pitch. As I have determined the pitch of the screw gauge by completely closing the screw gauge. By completely closing the screw gauge, we will give it 5 rotations, and then we will calculate the number of divisions which are moved on main scale. We have calculated our pitch as 1 millimeter. Then we will find the least count, which we have determined it to be 0.01 millimeter. Now, we will find the zero error. Zero error is determined by completely closing our screw gauge. That means, we will move our circular scale totally. If 0 and 0 coincide, as I am showing in this case, then the zero error is nil. But if on completely closing this type of error appears, then as both 0 are not coinciding, then there is a error. This situation can happen in this way also. In this way, if it is completely closed, we can see that both zeros are not coinciding. So, if zeros are not coinciding on closing, then there is a positive or negative zero error which we have to take into account. Now, in order to find out the diameter of a wire, first of all, we have to place our wire or a sphere for which we are finding the diameter in between the two edges by opening our circular scale. We can move our circular scale easily. Now, here we can measure the reading of main scale. As we can see that 6 divisions on main scale are visible. So, the main scale reading will be 6 millimeter. Now, we have to find the circular scale reading. The circular scale reading, we can see this is 20 and the 0 line of the main scale is coinciding with 22nd division. So, the circular scale reading is 22. This will be multiplied by least count 0.01 mm. So, this will give us 6.22 millimeter will be the diameter of this sphere. For a screw gauge which is having a zero error equal to nil. We have placed a sphere between these two jaws. For more accuracy, we will determine the diameter. We will observe the diameter 3 times. Here I have made a table for this. We have determined initially pitch by moving it, giving a full rotation 4, and distance moved is 4 mm. So, pitch comes to be 1 mm and number of divisions are 100, hence least count will be 1 mm upon 100, giving 0.01 mm, which is 0.001 centimeter, and if there is a zero error, we have to find it, and then we have to take main scale reading. Here the main scale reading I have shown is 6 and the circular scale reading I have shown is 22, and this 22 will be multiplied by least count 0.01 and the total reading will be observed here. It will be 6.22 is the total reading observed. We have placed our sphere in this direction, and the B reading means we have to place the sphere in a perpendicular direction. And for more accuracy, we are taking the diameter in 3 directions, and for the corrected value of diameter, we can add the zero error or it have been subtracted depending upon the positive or negative zero error. And finally, we will find the mean of this diameter, which will give us the result of diameter of our sphere which is given to us. Now, In this experiment, we have to take some precautions. The precautions we have, which we must take, that we must have a screw which should move freely without any friction, and we should measure the diameter of our wire or the sphere in two perpendicular directions so that accuracy can be more. And there are also some sources of error. We can have a wire or a sphere which may not be uniform, and the screw may have some friction also. So, we must have a frictionless screw, and the backlash error must also be avoided so that we can easily move so that we can have a accurate determination of our diameter of a wire or sphere which we are using. Backlash error means that we should try to move our screw only in a single direction. So, students, I hope that you have clearly understood what I taught you about the screw gauge and how can we easily and accurately measure the diameter of a wire or a sphere up till 3 decimals accurately using a screw gauge. Thanks a lot for watching.